preparing something very amazing to all of you. And we are going to be very happy that you can follow this series until the end. And please follow us on social media and subscribe to our YouTube channel. I'm sure you're going to be able to get to know what we are going to be doing for the next couple of months. And all the content of Congenital Heart Academy, it's there in the YouTube channel. We want to invite you for some activities that we are supporting. One of them is, this is very interesting for the surgeons. So it's a hands-on training on an online fashion. So it's very interesting. It's a training for the specific cardiac lesions done by 3D printing. So it's very interesting. You can actually practice, and you are going to have mentors teaching you how to do things differently, tips, tricks. And we are very happy to support this activity from Sick Kids in Toronto, and very happy that Sasha is one of the proctors of this activity. I'm sure this is worth trying for our surgical colleagues. And from Toronto as well, they had already recorded a very nice series about the history of pediatric cardiology. So this is very interesting for all of us to get to know from where we are coming from. And this, as we know, our specialty is a new one, so we don't have hundreds of years of tradition. So everything is still evolving, and it's very nice to listen to them talking about the history. So we are releasing this on our YouTube channel every Saturday. So every Saturday you can check on the YouTube channel and get a new episode of this very nice, very interesting series. We are happy to support the class of cardiac morphology from Pittsburgh, and this is going to be on the 17th and the 18th of September. This is going to be for free, and it's going to discuss TGA on the first day and CCTGA on the second day. We are very happy to have Dr. Anderson as faculty as well. This is going to be very amazing. I think it's worth watching, so please subscribe, register to that meeting. And today we are starting Dr. Anderson's series, as I said. Just before that, I want to remind all of you that we are going to have on the last Thursday of the month our fetal series. This has been amazing. The feedback that we are getting from the series is very nice. So if you're interested in fetal cardiology, please join us on the last Thursday of the month. And Dr. Silverman is going soon to restart his echocardiography series correlating morphology and the echo images. He's going to restart soon, as well as Dr. Mary Cohen. She's going to restart the echo series as well. And we are preparing nice webinars for all of you guys. So please follow us on social media. You're going to be able to see what we are preparing. So for today, we are going to set the scene for what we are going to have this entire series, understanding the cardiac development. So this is going to be a very nice session. I hope all of you can enjoy, and this is going to be on our YouTube channel. So please share the link with your colleagues if you think it was useful for all of you. Okay, so now we have Dr. Anderson. Thank you very much, guys, for joining us again on this new semester. We are very happy to have all of you.
Well, good afternoon to you all, ladies and gentlemen. And we're about to start a new season with the Congenital Heart Academy. Now, I'm going to start with several presentations on cardiac development. Those of you who were with us last year may have seen this slide before, because I'm asking the question, what is new? I am sure that all of you who are interested in the congenitally malformed heart will agree with the statement that is on the screen at the moment. And those of you who were with us last year will remember that it dates back quite some time. It comes from Maud Abbott, arguably the mother of the morphology of the congenitally malformed heart. And this is from the book she wrote in 1936. Now, those of you who have been with us previously will know that I've not always been a great fan of the role of cardiac development in understanding the congenitally malformed heart. And in the mid-1980s, along with Anton Becker, I wrote what is perhaps now considered an inflammatory chapter in a book where Anton and I suggested that development was a hindrance rather than a help. There was some justification for that at the time, because the concepts that were being put forward then were largely speculative. Nowadays, the whole thing has changed. And what I hope to be able to show you in the next 4 series, counting this one, is how an understanding of cardiac development can be a real help as we try to understand the anatomy of the congenitally malformed heart. And that is because nowadays the evidence comes directly from the Workbench. And I aim to share much of that evidence with you over the next 4 sessions. Because since my alleged retirement, I've been able to work at quite some length with a whole series of data sets prepared from developing mice using a technique called episcopic microscopy. This permits us to interrogate the data sets in 3 dimensions. These wonderful data sets were prepared by Tim Mohan, with whom I've worked quite extensively, and Tim, like myself, is now allegedly retired. Those of you who were with us last year will know that I've now been able to supplement this work in the developing mouse by looking at a series of reconstructed human embryos that were prepared by my other good friends, Llamas and Joe Explores. I'm going to share those data sets with you again. We would have hoped that by now these would be available for you to interrogate directly, because we're hoping that these data sets will go available on the web so that each of you can go through and can assess these interactive PD files. As yet, however, we're not able to post them. We hope to do that very shortly. I've also been able to supplement all of this information with the access that I have to a series of additional human embryos that have been prepared by serial histologic sectioning, along with still other human embryos prepared by Tim using episcopic microscopy. And it is this information I'm going to use today and for the next 3 sessions as we discuss normal human cardiac development. So just to let you know who these people are, this is a nice picture taken of Tim Mohan just prior to his retirement from Crick Institute. The institute made from the put together in London, still working very strongly in the field of molecular biology. And this is rather a nice picture of Jill when she received the award of her doctoral thesis. It's being presented by Llamas. Wout is wearing the gown of professorship in Amsterdam, but now he, together with Jill, are working in the University of Maastricht. And as I say, I'm going to be sharing with you the wonderful interactive PD files that they have made of developing human hearts. So today, I am going to set the scene, the understanding of cardiac development, and I'm going to introduce you to the various techniques we have at our fingertips. Then in subsequent sessions, first of all, I'm going to use this same information and I'm going to go into detail of what happens in atrial chambers. Then I'm going to look at the atrioventricular junctions and ventricular mass. I'm going to discuss with you the development of the right and left ventricles. And then in the final sessions, I'm going to devote my attention to the development of the outflow tract. And hopefully in these 4 sessions, we will set the scene, as I aim to do today, not only for the understanding of normal cardiac development, but to show how an appreciation of that normal development lets us begin to understand what goes wrong when the heart itself is congenitally malformed. Now, throughout these demonstrations, I'm going to be making comment on the stage of development of not only human hearts, but also mouse hearts. Now, to assess human development, we use what is known as Carnegie stages. And this dates way back into the early part of the 20th century, when Davis and colleagues, using embryos collected in the Carnegie Institute, described the stages of overall development of the human embryo. And they divided this into a series of stages. We are concerned with stage 10, which is about 4 weeks after conception, through to stage 23, 7 to 8 weeks of development. And it is at stage 23 that we move from the embryonic stage to the fetal stage. As you will see when we discuss the atrioventricular junctions, in fact, there are significant changes still to be made after stage 23, but by stage 23, septation is complete. So that is a key stage of development. We're then going to compare that with what happens in the developing mouse heart. And here we talk about embryonic days of development. So on my images, you'll see E something. And the days of development that relate to stages 10 through stage 23 in human development are E, embryonic day 8.5, through embryonic day 14.5. Now, there is then a significant difference, because although septation is complete in the mouse heart by embryonic day 14.5, no more than another 4 days lapse before the mouse gestation is complete. In the human development, as you all know, human development goes well beyond 8 weeks of development, and indeed, gestation in the human is typically 40 weeks. So there is a significant difference in the period of gestation, but despite that, the basic mechanics of development are comparable between the murine heart and the human heart. There are subtle differences, and we will discuss those subtle differences as we go through. But on all my slides, you're going to see these stages, Carnegie stages for the human, embryonic day stages for the mouse, and I'll refer to them at the appropriate points. So let's set the scene then for cardiac development. And what I want to discuss with you today is that the way we get formation of what we call the primary heart tube, I want to discuss with you how that heart tube then loops, and it is that looping, the heart tube, that sets the scene for the changes that permit us to distinguish between morphologically right, morphologically left ventricle, and also between the morphologically right, the morphologically left atrium. And then I'd like to conclude our scene setting session today by looking at significant changes taking place in the embryo itself, particularly concerning the extrapericardial arterial trunks. So let's start with formation of the primary heart tube. And indeed, at the beginning of the 4th week of development, the embryo doesn't look much like what we think an embryo looks like at all. It's very much plate-like. And at this stage, when we recognize what we call the embryonic disc, we see the first formation of cardiac components, and they're forming at the cranial end of that disc. So if we look end on at the disc, and here we're looking at the surface of the disc from above, so there it is disc-like. We know at the caudal end of this disc, we have what is known as the node. Stretching behind the node, we have the primitive streak. The disc itself has an ectodermal layer, and it has an endodermal layer. And then coming out from the primitive streak, we know that there are mesodermal elements that migrate between the ectodermal and the endodermal layers. And it is those mesodermal elements that have migrated from the primitive streak that we call the heart-forming areas. There are then further migrations of cells from these heart-forming areas towards the cranial end of the plate, and there they form what is known as the cardiac crescent. And we know that there are temporal progress in formation of this cardiac crescent, so that first we have a first lineage, also known as the first heart field. And then with ongoing migration from the heart-forming areas, we have second lineage, second heart field, and nowadays that second heart field is itself divided into additional areas. And what this means is that from the heart-forming areas, there is continual addition of material to the initial primary heart tube. So if we look at a reconstruction of an embryo at this early stage, here you see 27 days rather, the end of the fourth week of development. This, in fact, is Carnegie stage 9. So one stage before Carnegie stage 10. And there you see the ectodermal layer, which is going to form the neural tube of the embryo. There is the endodermal layer, which is going to form the gut. And then between the two, you see those migrations, heart-forming areas, and already they are enclosed within a developing pericardium. The beauty of having these interactive PD files prepared by Wout and Jill is that we can take away the coverings of the heart, take away the ectoderm, the endoderm, myocardial components, and we can see the lumens of the heart. So this is what the lumens look like at this early stage of development. And you see that there are arterial plexuses developing at the head end of the primary heart tube. There are venous plexuses developing at the tail end. And between the two, at this early stage, we have two endothelial heart tubes. Now, those heart tubes then come together, and at this same stage, we see that they are beginning to be enclosed by myocardium, which is being derived from the myocardium crescent. And within the heart tube, we're beginning to get formation of cardiac jelly. If we go one stage further, we can see the beginning of the formation when it starts to look like an embryo. Because we can see that the neural elements are beginning to fold over what eventually will be the mouth, and we can recognize those as the head folds. The gut is also becoming much more gut-like. There between the two now, we have the pericardium. And we can also see the development of the transverse septum that eventually will become the diaphragm, and that is going to separate what will be the chest from what will be eventually the abdomen. And at this stage, the heart is forming in the neck embryo of the developing, the neck region of the developing embryo. If we now look at the lumen, we can begin to see that primary heart tube. We can also see the venous structures that are bringing the blood back from the placenta into the developing embryo, the umbilical veins, they are bilateral. And we see the venous plexus that is developing on the yolk sac, and we call that the vitelline plexus. And they come together to form bilaterally symmetrical venous tributaries. And they enter into the primary heart tube. And at this early stage, 4 weeks of development, the heart tube is primarily what is going to become the left ventricle. Already, however, additional cells are beginning to grow into the heart, what we call the second heart field, and they are going to form the outflow tract. Rising from the outflow tract, we have the aorta. Same embryo, but now Jill and Wout have put in the myocardium. There you see the myocardium that is clothing that cavity of what will eventually be the left ventricle. We know that is derived from the first heart field, and we begin to see the development of the right ventricle, and that is clothed by myocardium derived from what we call the second heart field, or that second lineage. So, at the end of the 4th week of development, we have a heart tube, and it's surrounded by myocardium, and we call that myocardium primary myocardium, because at this early stage, there is no way to differentiate what is to be right ventricle, left ventricle. In order to differentiate ventricles, also the atrial chambers, we need to have formation of what we call the chamber myocardium. And that forms by a process of what is now known as ballooning. And in order to get ballooning, another thing has to happen, and that is that the heart tube has to bend. And it is bending that creates the ventricular loop, and that sets the scene for formation of the definitive chambers. So here I've taken you on one stage, now Carnegie stage 11, so we're beginning the 5th week of development, and now you can see the formation of the ventricular loop. You can also recognize the atrioventricular canal is entering one end, the outflow tract is coming out of the other end. But still, at this early stage, the walls of that heart tube, myocardial walls, are still primary myocardium. But the stage has now been set for this process of ballooning. Now, ballooning was brought to prominence by two other very good friends of mine, Anton Mohan, like myself, now retired. He was the professor of anatomy at the University of Amsterdam, and he worked with Vincent Christoffels, and Vincent took over from Anton as the professor of anatomy and development in the University of Amsterdam. And this is one of their very nice cartoons that shows you what is going on when we have ballooning. What you see in gray is the remnants of the primary heart tube. And there, from the atrial component of the heart tube ballooning in parallel, in blue, you see the formation of what will become the atrial appendages. And I emphasize again, the appendages are ballooning in parallel. What you see in red are the apical ventricular components, and they balloon in series. So the apical component of the left ventricle balloons from the inlet of the loop. The apical component of the right ventricle balloons from the outlet of the loop. And this is key to how we recognize the ventricles. So the same stage now, but this time we're looking at a reconstruction of the heart itself. This is another of the PD files prepared by Joe and Wout, and you can actually see those ballooning components. So there is the ballooning right atrial appendage, the ballooning left atrial appendage, the apical part of the developing left ventricle, the apical part of the developing right ventricle. And it is these ballooning components now that permit us to recognize what is morphologically right, what is morphologically left. But how do those parts become morphologically right as opposed to morphologically left? And what is the influence of looping? Well, they develop their right as opposed to left characteristics under the influence of what we know as the laterality genes. And there are two key genes. One is called PITX2. This is part of a family that also includes the sighted gene. And it is PITX2 that produces morphologically leftness. And that is the dominant gene. There are another series of genes. Here I mentioned two of them, lefty one nodal. You can also put sonic hedgehog into this family, and they create a midline barrier, and they stop the gene that produces morphologically leftness migrating to the right side of the developing embryo. And I can demonstrate to you the influence of that by looking at this picture of a developing mouse heart. This is a scanning electron micrograph. It's made by my other good friend and colleague, Nigel Brown, with whom I worked for several years at St. George's Hospital in London. And Nigel made this, as you see, at embryonic day 8.5, and he did it by removing the pericardial cavity. And there is the developing linear heart tube. And we can take a line down the middle, and we know that everything you see to the right side, which is the left side of the embryo, is under the influence of those left genes, PITX2. Everything you see to the right is not under the influence of PITX2, because those other genes form the midline barrier, and they stop PITX2 influencing the right side of the developing heart. But look what happens after we've had looping. This is another of Nigel's very nice scanning electron micrographs. You see a day has gone. We're now into embryonic day 9.5 in the mouse, and the heart tube has looped. But now the atrial component still has a right and a left side. And so when the atrial appendages balloon from this part, the right one will not be under the influence of PITX2, because that midline barrier will have meant that PITX2 can only influence the left side of the developing atrial component of the heart. But when the ventricles balloon, then each of them, whether they balloon from the inlet or whether they balloon from the outlet, they will be equally influenced by the genes producing leftness or rightness. And so something else is going to determine what makes the ventricles morphologically right, morphologically left. The genes themselves, however, influence the atrial chambers. So this is a mouse in which we've knocked out PITX2. There is no influence now to produce morphological leftness, and so we have bilateral right appendages. And this is another mouse prepared for me by Professor Maino from Japan. Professor Maino knocked out lefty 1, and this let PITX2 influence both sides of the developing atrial chambers. And there you see bilateral morphologically left appendages. And that is why it is only the atrial chambers that show the features of isomerism, and why those features are limited to the atrial appendages, because they are the parts that balloon. Everything else is variable, should be described when abnormal, and that is what we're going to do as we continue our sessions and we look at the congenitally malformed heart. So let me now finish by sharing with you some comments on what is happening outside the heart. Because all the time things are happening inside the pericardial cavity, equally important things are taking place in the remainder of the embryo. And it is these changes that are going to set the scene for the formation of the venous tributaries. We're going to talk about that next week when we talk about atrial development. And they set the scene for the understanding of the arterial pathways. And I will discuss that with you in my 4th session when we talk about development of the outflow tract. So let's go on just a little bit, and let's look here at an embryo that is at Carnegie stage 12. As you see, 30 days of development. We're just at the beginning of the 5th week of development, and I am showing you now the embryo from its right side. And Jolen-Wout's interactive PD file is complete. These are all the parts I have reconstructed, and you can see that the embryo does indeed look very much like what we expect an embryo to look like. But let's concentrate first of all on the venous component of the heart, because now we can see entering the pericardial cavity, we have those veins that developed in relation to the yolk sac. As I told you, those are the vitelline veins. We can see the veins that are bringing back the blood from the placenta to the heart. Those are the umbilical veins. And now, by Carnegie stage 12, 30 days of development, we also have the veins that have developed within the embryo itself, and we call those cardinal veins. And what you can see is that the veins are coming together into a venous input, and we call that venous input the sinus horn. What you cannot see in the way I've taken this particular image is that at this stage of development, right side, left side are symmetrical. But we will discuss that next week, talk about development of the atrial chambers, and I will show you how that symmetry disappears so that systemic venous tributaries become confined to the right side of the developing atrial chamber. But let's also look at the developing head part of the extrapericardial components of the heart. And what I want you to concentrate here, again, we're Carnegie stage 12, just at the beginning of the 5th week of development, is that ballooning out of the gut itself, we have what are called the pharyngeal pouches. And there, between the first pharyngeal pouch and the mouth of the developing embryo, we have a pharyngeal arch. And at this early stage of development, percolating through the pharyngeal mesenchyme of that arch, we have the first pharyngeal arch artery. And at this stage, you can then see that there is a second pharyngeal pouch that is ballooning out from the cavity of the gut. So that means between the first pouch, second pouch, we have a second pharyngeal arch. And within this arch, rising from the arterial pole, developing heart, we have the second arch artery. Now, when we track development forward, things happen very rapidly in this extrapericardial area between the developing heart, the developing pharynx. So here, I've only gone one stage further, 32 days now, so we're into the middle, 5th week of development, and there is the first pharyngeal pouch. But now, the artery that was associated with the first pharyngeal pouch has disappeared. There is the second pharyngeal pouch, and still we see the second arch artery. But now we can see that there is a third pharyngeal pouch, and that means there is now a third pharyngeal arch. Percolating through that third pharyngeal arch, we have rising from the manifold, which is in the front part of the pharyngeal mesenchyme. We'll talk about that when we discuss the outflow tract, the aortic sac. Arising from the aortic sac, we have the third arch artery. But also now, we can see that there is a fourth arch artery forming, although as yet, we cannot see a fourth pharyngeal pouch. But there will be a ballooning from this part of the gut that will form the fourth pharyngeal pouch. And indeed, we see that when we move to the end of this 5th week of development, 34 days, Carnegie stage 14, next stage of development. And now I'm showing you the first pouch, which is lost its artery, second pouch, no artery any longer in the second pharyngeal arch. Still, however, we have the third pouch, the third arch artery, fourth pouch with the fourth arch artery. And now we have formation of still another arch artery. But this time, there are no further pouches to be formed. And this is crucially important because this relates directly to how we are going to describe the pharyngeal arches and their arteries. Because what I have shown you, there are never more 3 arch arteries present at the same time. So I know that if we take many textbooks, you see the picture drawn of 6 arch arteries. This is a total myth. There is no evidence anywhere in mammalian development to support the notion that there are 6 pharyngeal arches. And so it is for that reason that I have called that artery that will give rise to the pulmonary arteries. Indeed, on the left side will persist as the arterial duct. That is why I have called it the pulmonary arch artery. And this is what we're going to do when we discuss development in the outflow tract. Because if there are only 5 pharyngeal arches, that means it is that pulmonary arch artery that is the 5th arch artery. But it would be terribly confusing if I suggested we renamed that artery as the 5th arch artery, because many of you will know that there are multiple lesions nowadays that are interpreted on the basis of persistence of a 5th arch artery. In fact, when we get to discuss development of the outflow tract, I'm going to show you that those alleged 5th arch arteries are much better explained on the basis either on persistence of collection channels or remodeling of the aortic sac. And it is for that reason I'm not going to talk about a 5th arch artery at all. I'm going to talk about the 3rd, 4th arch arteries, become the systemic pathways. I'm going to talk about the pulmonary arch arteries, and it is those pulmonary arch arteries that form the pulmonary pathways. So what I've tried to do today is to set the scene for 3 sessions that are going to follow in which we discuss cardiac development. And I hope, first of all, what you've seen, that in terms of cardiac development, so-called segmental model, where there is a bulbus and a primitive ventricle and an atrium, that is totally redundant. We can now describe everything on the basis of the developing atrial chambers, developing ventricular chambers, the developing outflow tract. I've shown you cardiac development is dependent on ongoing contributions from those heart-forming areas into pericardial cavity. And we now talk about that in terms of contribution to the developing heart, first heart field, second heart field. And we will develop that concept as we go on. But particularly important, I've introduced you to the concept of ballooning, very nicely illustrated by my colleagues in Amsterdam. And it is the ballooning primary heart tube that produces those components of the developing chambers that permits them to be distinguished as being morphologically right as opposed to morphologically left. And I finished by emphasizing that there are only 5 pharyngeal arches. That will become important when, in our 4th session, we discuss development in the outflow tract. But hopefully, that sets the scene for our ongoing discussions of normal cardiac development.
Thank you very much, Bob. It was amazing, as usual. And we are open for questions. Dr. Diane is here, Dr. Silverman as well. So please, guys, type your questions on the Q&A chat box. In this meanwhile, let's see if the audio of Dr. Silverman is back. Hi, Norman. Say something. Let's see if you fix it. No, still no. We can't hear you. Do you have a microphone? Do you have earphones that you can connect to your computer? Maybe can help. Okay, great. So if you can get one, because unfortunately we can't hear you. And if you have some earphone, but now you're muted. Oh, now he's off. Okay. Diane, do you want to add anything?
Diane is also still muted at the moment.
No, I'm not. No, I'm not. This is all very interesting for me because over time I have learned kind of backwards how congenital anomalies form by all of this new embryologic data that's out here. And it has helped me tremendously with my teaching, and all of the medical personnel that I do teach currently have many questions for me based on the development. But once all is said and done, everyone is much more able to understand all of the processes that go on to form the different congenital malformations. And this has all been very helpful to me. So I think the beginnings of this session will be very helpful to everyone else out there as well, to put all the puzzle pieces together.
Indeed, you're right. This is very helpful. We had something like that last year, and it helped me particularly a lot to understand the cardiac lesions based on the development of the heart. It's something that helps a lot, and it's easier. You don't need to memorize a lot of things. You can understand why things can happen because you know how the normal development was supposed to happen. And Dr. Anderson can explain that in a very nice way. While we wait for Dr. Norman to come back, there's one question from Gupta. He's asking, pulmonary arch artery is 5th or 6th pharyngeal arch artery?
Well, as I explained, there are only 5 pharyngeal arches. So is this Saurabh Gupta?
Yes.
Saurabh knows this. We've written papers on this, and he knows that although initially we described 6 arches, we were wrong. And this notion that there is a 5th pharyngeal arch artery, we thought we had found one candidate for it. But we now think that that thing that we saw is much better described as a collateral channel. But as I explained, I think it would be confusing if I called the pulmonary arch artery the 5th arch artery, because everybody is then going to think it's what everybody else calls the 5th arch artery, whereas in reality, there isn't a 5th arch artery as currently described. There obviously are pulmonary arteries, and those pulmonary arteries take their origin from the undersurface of the ultimate of the arches, of the arteries that develop within the pharyngeal arches themselves. There are only 5 pharyngeal arches. So I think that that ultimate arch is better called the pulmonary arch. And in fact, that suggestion was made quite some time ago. It was made by Marco de Ruyter, who worked, and I think Marco is still working in Leiden. And quite some time ago now, Marco suggested that we should call it the pulmonary arch artery. I was not aware of that until relatively recently. I think if we call it the pulmonary arch artery, it puts everything into context. We then realize the arterial duct is the communication between the pulmonary arch artery, the systemic arch arteries, and the systemic arch arteries are the remnants of the third and fourth pharyngeal arch arteries. So the first and second pharyngeal arteries essentially disappear. And as I showed in Wout's wonderful, and Jill and Wout's wonderful reconstructions, by the time you see the third and fourth arch arteries, the first and second arch arteries have essentially disappeared. Little remnants of them persist as components of the head, of the facial artery, the ear artery, but essentially they have disappeared. So I think we can get rid of a lot of confusion if we recognize that there are only 5 pharyngeal arches. If there are only 5 arches, there can only be 5 arch arteries. And so we should call the ultimate one the pulmonary arch artery.
Okay, Norman, let's see if it's working now.
Do you remember the model that Dr. Van Merel produced?
I do, yes.
Do you still have the images of that?
I probably have them somewhere, but I don't. He also only ever found five pulmonary arches, and he never found in that what there are collateral channels, and that's the other point that we make. So collateral channels, in fact, in mouse embryos, we found collateral channels in half of all the embryos, and they are at the termination of the pulmonary arch artery, the systemic arch arteries, and they form these collateral channels close to the descending aorta. And Dr. Van Meerop, in his model, he showed those collateral channels, but again, he never produced anything with 6 arch arteries. I have the picture somewhere, but I think the reconstructions themselves are still in Florida, are still at Gainesville, are they not?
They are. They're in Dr. Bleiweiss's office. And I just pulled them up on my other computer. I would share them, but I don't have them on this computer. But I can send them to you.
I think I have them somewhere. We included them in the paper that I wrote with Simon Bamforth and with Saurabh Gupta, and at the time we were still holding to the fact that there might be 5th arch arteries, but we've re-evaluated our opinion there, and we wrote a commentary recently in Cardiology in the Young that accompanied a very nice paper describing the right arch arteries that came from India, and we explained in that now we think it's better to recognize there are only 5 arches. That the data supporting that came from Anthony Graham and his colleagues in King's College in London. And they showed conclusively that in no mammalian species are there ever 6 pharyngeal arches. So as I said, it's a myth.
Okay, we have one more question, and this was my mistake. It was not from Sharab. It's a Shubham, very a similar name, Gupta. So it was not his question, but he's asking now, please explain parallel ballooning of atrial chamber. I think we're going to cover that next session, right?
I am indeed, but I can tell you again that everything depends on the fact that it is only the atrial chamber that is able to respond to the laterality genes, so that its right side becomes morphologically right, its left side becomes morphologically left. The laterality genes will influence the right ventricle and the left ventricle in comparable fashion, because each of those ventricles has its own right and left sides. And that is why we only ever get isomerism involving the atrial chambers and specifically the atrial appendages. And as you say, we will discuss that again. I kept on saying next week. In fact, it's in a fortnight's time, because we need a little longer. It's quite hectic to have to prepare everything for every week. And you'll note that we're not quite on song for doing it even at 2 weekly periods, because we're going to have quite a hiatus between October and November, and that's because October rather, is full of lots of other things happening, like the Pittsburgh Masterclass that we're going to be broadcasting.
Yeah, so the exact dates are on the Zoom link and on our social media as well, guys. And you received for sure our newsletter with the correct date for Dr. Anderson's sessions. We have a question from our dear Carlos Troconis. He's asking, related to that, is pulmonary atresia a block out of the fifth pharyngeal arch?
The pulmonary atresia really is a block between the intrapericardial and the extrapericardial arteries. So typically pulmonary atresia is found at infundibular level. So in fact, it's something happening within the heart. What is interesting in pulmonary atresia is whether there is formation of the intrapericardial pulmonary arteries, and that is the key. And that's an interesting thing itself. Well, we will have a session when we get on to discussing the specific lesions. We'll talk about what happens in what I'd like to call tetralogy with pulmonary atresia. That's often called pulmonary atresia with VSD. I think that's much too broad a topic, because it's only in tetralogy with pulmonary atresia that we have major aortopulmonary collateral arteries, and they are intimately concerned with what happens to those extrapericardial pathways, but the atresia itself develops within the heart, typically at infundibular level, but it can also be at valvar level. And again, then the key is whether we have it with an intact ventricular septum or with an interventricular communication. But we will have a session and we'll talk specifically about that almost certainly in 2022. So we're going to keep going. I can tell you, tell the people who are watching that for the rest of this year, we will complete our sessions on development. And then Diane is going to join me along with Adrienne. And we will then lead up to Christmas with 3 sessions that we're going to devote to cardiac anatomy. And then when we move into 2022, then we'll start discussing the lesions. And it depends how much stamina anybody has as to how far we go in 2022. But we'll try and we're going to do our best. Has Norman made his microphone work yet?
Let's see. Let's try, Norman. Still not working.
I mean, the best thing of all is we can see Norman and we can't hear him, because so it's good that we're able to see Norman and we can't hear him. So Norman, nice to see you.
It's a shame. His comments are always very important. This is a shame, unfortunately. We can go back on that in the beginning of next session, Norman. Don't worry.
Sort out his microphone or something. He's got up very early to join us today. I know it's very early in Palo Alto, so it's good to see you, Norman.
Yeah. We can listen anything, Norman. Sorry. Did you update your Zoom? There's a new update. Maybe that's what you did. Okay, so I don't know. Okay, guys, I think we don't have any other question on the Q&A chat box. I know we have one. Let's see what it is. Okay, there's one. He's saying, Gupta is saying again, there is some different data in Mavrodis, pediatric cardiac surgery. So which data to be kept in mind?
Where is he saying the different data is?
Mavrodis?
Oh, in the Mavrodis book is an old book. This says the new evidence says only Anthony Graham and his colleagues only published their data, proving that there were only 5 pharyngeal arches in 2019. So it's only since 2019, and it's in fact only since 2019 that I've had access to the data from Jill and Wout. And I think everybody who's seen the data I presented today can have seen from Jill and Wout's interactive PD files that unequivocally there are only 5 pharyngeal arches. And this is the bottom line. If there are only 5 pharyngeal arches, there can only be 5 arch arteries. So this is new data. I mean, the textbooks take a long time to catch up, and I think our own textbook, Saurabh Gupta and myself produced a chapter on the 5th arch artery, so we need to revise that when we move into the next chapter. In fact, Mavrudis and Bakker rather are redoing their textbook. There's another textbook that's coming out that's being done by Raed Abdullah from Lurie Children's Hospital in Chicago. And in those textbooks, we will emphasize the fact only 5 arches. You only have 5 arches. There are only 5 arch arteries, and that is the bottom line. So it's new data. It takes a little time to percolate through, but nowadays with the internet, and particularly that we're able to spread the news on the Congenital Heart Academy, we now know that there are a lot of people know what's going on. So we can update all the time through the Congenital Heart Academy.
This is an honor for us to be able to have great speakers to spread the most up-to-date data of everything, all the topics that we've been talking about. Guys, thank you very much. It's a pity that Dr. Silverman was not able to give his comments today because they are very precious for us, but you can keep them, Norman, for the next session. We can start with your comments about this session on the next one. And thank you very much, guys. Thank you for attending. Please share the link on YouTube with your colleagues. I'm sure this, particularly this beginning of the series, is going to be very, very helpful for everybody to understand cardiac anatomy and later cardiac, the diseases of the cardiovascular system. Thank you very much. Thank you very much, Dr. Anderson, Diane, and Norman. Bye-bye, guys.
See you, everybody.
Bye.
Look forward to seeing you in 2 weeks' time.
See you then. Bye.
Bye, thanks.